Alright class, in this video we're going to talk about basic exponential functions. So a basic exponential function is f of x equals a times b to the x. Now let me specify when I say basic. We're expecting when we're talking about basic exponential functions for a and b to both be integers. Okay? If they're not integers, then you need to use another format. Okay? And we'll talk about that. So let's say if we have the function 2 times 3 to the x, let's say the first thing we want to know, how would I sketch a graph? Okay, well, this point, this number here, 2, would represent what we call the initial value. Meaning, if I substitute 0 in, 3 to the 0 is 1, so 2 times 1 would be 2. So in other words, looking at that number a, we're talking about the value 0, 2 on the graph, or 0a, depending on what the value of a is. And from previously, we had mentioned exponential graphs. So we know the y-intercept here is 2. So we know an exponential graph of this form is going to look like this. We know that that function has a horizontal asymptote of y equals 0. And we know that this is what we call growth. And that's when the b value, the base, is larger than 1. Okay, consequently, if f of x is 5 times 1/3 to the x, okay, so how would we sketch that one? Well, the y-intercept is still going to be 5, so that's going to stay the same. But in this case, the base is 1/3. When I raise 1/3 to a really large power, it gets teeny tiny. So it's kind of like the previous one. You can also think about it as 5 times 3 to the negative x. That's helpful when we talk about transformations because f of negative x is f of x reflected across the y-axis. So in that sense, it's the opposite of growth. Okay, so it looks like that. And once again, it has a horizontal asymptote of y equals 0. And this would be called decay. And this happens when b is between 0 and 1. Okay? What else? When I say find the equation of. So find the exponential function. Don't do that. Here it is. Containing the points 0, 3, and 2, 12. Okay, so this is a relatively simple problem, and you may be looking at it and you may already know the answer. Okay, so let's talk about what mathematically you need to do to make sure that we understand why it's the answer. Okay, so first of all, f of x equals a times b to the x. We've got nice, lovely whole numbers there, so we're hoping something nice is going to happen. Oh, sorry, didn't mean to. Earthquake. Okay. So what's going to happen here? So 0, 3, so we know from before that if we have 0 common number, that's a. So a equals 3 because 3 is equal to a times b to the 0. b to the 0 would just be 1. Okay? So what can we do else? So 12 is what we get. We already know a is 3. 12 is what we get when we substitute 2 in for x. So that gives us a lovely little equation. We can divide by 3. We get 4 equals b squared, which would mean b is plus or minus 2. Now let's talk about that. Okay? Exponential functions do not have negative bases because that would create all kinds of issues with the domain. You wouldn't be able to plug in a value of 1/2 or 1/4 or anything that's even in terms of a root because that would be a negative number to a root, complex number. So in this case, f of x has to be 3 times 2 to the x. And once again, I know lots of people could go straight to the end just by looking at those things and figure that out. But we want to see a little bit of a systematic way of deriving it, okay, and proving it. So let's do the same. It's always easier when they give you the y-intercept. So we're going to do the same with -1 10, and 2 over 25. So I want to show you a nice little trick for this one. So first of all, if we think of it the same way as we thought of the last one, f of x is a times b to the x, and you can just substitute things in. So 10 would be a times b to the negative 1, and 2 over 25 would be a not b, a times b squared. Okay, and you can, that's a simultaneous system of equations. You could solve for a and substitute in the other one. That's fine. If you want to do it that way, that'll work. But one thing I want to show you that's kind of nice and neat. So if I'm looking at those two values, I'm going to take the one with the largest x value, and I'm going to put it over the one with the smallest x value. So the one with the value of 2, the one with the value of negative 1. And notice that this is the same thing as saying a times b squared over a b to the negative 1. And if you simplify that, the a's cancel, and you're going to get b cubed. And then over here, we'd have to flip my fractions, right? So we got 2 over 25 times 1 over 10, and we got some cancellation there, right? And that would multiply out to give me 1 over 125, and we can recognize that b is going to be 1/5 from that. Okay, so then what would my final answer be? F of x would be, what did we get? 2 for, oh, we didn't find a, but the a is going to be 2. We can easily sort of see that from one of those points. So this would be 2 times 1/5 to the x. Let me circle that because I'm running into the other part of the problem. All right.